Okay, let's start the class. Good morning, everyone. Behind there, here. So this is the second week, all right? So the second week we're going to move to the new topic, all right? And as you see, this is the topic, and I did some of the changes for this topic, very last minutes, and I did upload this topic to my time. You can check. So, for this week, this topic is quite, I guess that the most important, comparing to the logic gates or digital circuit and so on. This topic is quite, I guess, is quite fun. Okay, I like this topic, and maybe some of you are familiar with this topic. And we know during the lecture and the tutorial, who's from under Alpha team, I already told you that. Talk about that computer machines, okay? So computer machines, the computer machine itself have their own language. So like us, we also have our native language. I'm still recovering myself, sore throat. All right, anyhow, for this topic, we not only call as arithmetic for computers, we also call as digital numbering system. Digital numbering system. So what we call digital numbering system, as a human being, we understand that we used to have alphanumeric. So alphanumeric actually combinations of the letter A, B, C, D until Z. And after that, we also have the combinations of the letter plus with the numbering. So as a human being, we understand the numbering. We are following the ASCII. You know, right? ASCII, American Standard Code. So this ASCII come up with the numbering, which is, if we are doing a programming, so we used to have integer as a number. 1, 2, 3, 4, 100, 400, 1000 is an integer. That kind of a types of numbering. And we also have a fraction number. Fraction number, which is, it has decimal, which is, it has the point. For example, 52.30, for example, 21.33. So it has a point, decimal point, placing of a positions of the digits. So in the computers, computer doesn't understand this number 302. You're giving the number, let's say you key in, you want to key in 100 plus 1. Okay? What computer understand, 100 is different number and 1 is a 1. If you're giving the computer instruction which is 2 multiplied by 3, computer doesn't understand 2 and 3. But computer understand binary code. Okay, faster, the one that came late. All right. So in a computer system, as I said, it has their own language. So we need to understand the language. Because as I mentioned, in the computer system, when we're giving the set of instructions to computer, and computer will execute, first foremost, what computer doing is to decode. It means it's convert our language to their language. So machine language basically is the lowest language in computer study. So you have a machine language at the bottom, and you have the third language, and after that you have object-oriented, the one that you have right now, like a Python. You just simply can drag and drop. You have a compiler, you have an interpreter. So that is a high-level language, object-oriented. The language that we're going to learn actually is involved with the numerical system. So this is the topic. If you look at this topic, there you are. We call that is the radix system, radix, or a basis system. Actually, we have many bases until base 36, you know, because we want to cover the numbering 0 until, billion, and cover the letter A, small letter and capital letter to Z. So if you try to Google or ask the ChatGPT, they will say, what is the biggest basis in computers language? So it said base 36. Okay, it's a total with the rumble jungle of the number and also alphabets. all right? So it seems like a Morse code. It's representing set of a number in the binary. So we understand that computer's language is using binary, okay? So this is the topic we're going to cover. And based on my experience, like yesterday, I can't to cover all because it's a lot, all right? But I have tips for you. So as usual, in my class, my style, I think what? Just pick up the gist during lesson, okay? So we talk about this. In the numbering system, we have one. The first and foremost is the 2 complement, which is base 2. Whoever that already uploaded this slide and then run through, I guess that is good. I appreciate that eventually before you start your class and you review the slides. All right? The first one is a complement 2 or base 2. And base 2 is the basics of the fundamental of numerical system in computer. We call binary, base 2. It's the smallest base in computer system. Second is the decimal. Basically, we have octal. Okay, if you were following the, the structure, we have a complement 2, and then complement 8, and then complement 10. And next, the biggest, which is complement 16. So that's the name. So we will cover this one. What the gist for today's topic? Okay, you scroll down, go to the last page. All right. So your midterm test. So there are students asking what the midterm test for even second weeks because your midterm test is the week 7. Is that involved with this topic? Yes, it is. Yes, it is. So we're think that what you need to pick up for today's lessons, okay, I'm going to giving you the skin of this numerical system. So during tutorial, co-lecturers, my co-lecturers, whatever the term they use, instructor, tutor, will helping you in detail. So we just go to the skin in the first place, all right? So there is a concept when you want to do the conversion, okay? First of all, what you need to know, what is a base 2? And then base 8, octal. Base 2 is a binary, base 8 is octal. And after that, you need to know about the decimal base, base 10. The last but not least is you need to have a hexadecimal, base 16. Enough. So if you read question number 4, take a minute and read question number 4. What is that? It's conversion. So this is the gist for today's topic. What will be in your midterm? This one. Okay? You need to know, 1, in the first place, what is the basis? Number 2, how to convert from this base to another basis. Okay, for example, from binary, base 2, to base 8, octal. Example. Another example, if I ask a question, convert binary to decimal, base 2 to base 10. Or, I'm giving a little bit challenge, convert base 16 to binary. So, nevertheless, the thing is, in this, okay, if you read question number 4, it seems like, oh, so complex, No, it's very simple. It's very simple. You just need to get the concept and formula. That's it. And formula the concept only 2 in this study. I don't know why you are study about this topic. I mean, like previous, okay, every single of a student who are taking computer science and software engineering, it's a compulsory to know about this conversion, and then I don't know why it's so difficult to convert. Basically, it's a very simple step, only 2 steps. So let's go. But before we go rumble and these things, I want to go for the introduction to the all bases, and you need to know about that one. Okay? So back to this one. First of all, arithmetic logics, I did mention in the tutorial what is important about the arithmetic logics. Once you give it instruction to the computer, for example, I said you go to the calculator system, you open calculator system through your mobile phones or your tab or your laptop. What happened? You want to do calculation. 1001 plus 2000, blah, blah, blah. For example, it's already instruction. But this instruction including the operations of addition, for example. Oh, so the processor will go to the arithmetic logic units because only this has the instruction to execute your instruction. I mean, you give instruction, computer also have instruction. So CPU will giving the instruction to AL unit, please convert this one and calculate. And then display to the output. Okay, input, process, output. Input, process, output. Remember? All right. So arithmetic logic is a LU. Okay, it's very important to do the conversion, decode process. Okay, and then, you know, this is a very popular question in the final exam. Eventually every semester, we're asking your student about this. Machine cycle. Machine cycle. All right, we're going to go this one in the, I think, week 3 or week 4. We talk about instruction set because each computer has the instruction sets. Yeah, so we're going to talk about this one later. But the most important, basically, if you can see that, there is a table on your left and the right. So what happened in the machine cycle, ALU unit, what is actually important in this topic before we know and understand how that computer convert that numbering instruction by you, given by you. So in the first place, they fetch the data, okay, from the input device, fetch the data. After that, they want to execute, but they can't to execute. Your computer machine can't to execute because of it need to decode, because their language is binary, correct? So they're going to decode. Decode is a process to convert any of a numbering, any of the alphabets, any of the instructions towards to their language. I mean the computer machine language. After they decode, they execute. What operation? It is logic, true and false. You ask to print the document. For example, is it true? How many copies? So ALU unit will doing that. Logic unit will be doing that. You want to compute blah, blah, blah number with the formula. So ALU unit also will going to execute that. After they execute, they're going to store the data or else display to you. Khalas. Done? Clear? I need to talk too fast a little bit, you know, today because we want to cover a lot. If I can't to cover a lot, we're going to continuing during tutorial. But I hope we can do. All right? Because last week, yesterday also I have a class. So this is like repeating class. Okay, numerical number. You see in that table, it has decimal system. Why decimal system at the first place? In that table, the first column. Why? Anybody knows? I think you're familiar with decimal system. Is it? Did you familiar with binary system? Octal? Little bit. Hexadecimal? Okay. We asked the student because she, yes. You said you understand hexadecimal system? Okay, let me know what is hexadecimal system. Okay, my student here, not my student. Okay, our friends here, okay, she said that she knows about hexadecimal. Hexadecimal is a numbering system which is from numbering 1, okay, towards to the number 9. And that's actually the digits. When they come to the number 10, to the rest is using to have an alphabet like in that columns. You know, what else you said just now? And it is a numbering system using a base 16. That's correct. Give a pause. So I know she's doing her homework about this topic. Okay, for those the rest, you're familiar with you're familiar with the decimal system, right? 0, 1, 2, 3, 4, 5, 6, so on. So I also familiar with that numbering. But because I'm teaching this almost like 14 years, so I'm familiar also with binary number. If you look at the binary number, okay, it's a computer language. Let's say you pick up number 10. Pick up number 10 decimal system. We understand that this is number 10. Or you pick up number 11. We understand that's 11. But in the binary number, you see in the back there, okay, if a 10, 1, 0, 1, 0, that representing number 10 in our language. Computer representing number 13 as 1101. How we get it, that number? My tutorial I teach you, but the others I do not know whether your lecturer teach you about this one. But I don't want to mumbling about this thing, okay, because I want to go to numbering system now. All right, the most important basically is binary number. Okay, we have the formula. Look at to the numbering. When I say base 2, smallest base. After base 2, we have octal, base 8. Okay, little bit bigger, all right? Base 2, base 8. After base 8, we have base 10, our numbering, decimal, base 10. Increase little bit, we have a base 16. So from the small to the big number. Okay, I repeat, base 2 is the smallest. Then we go to base 8, octal. Then bigger, increase, base decimal, base 10. And the last, base hexadecimal, base 16. Small to bigger. Okay, so how we want to convert the number from the small base to the bigger bases? We're just using multiplication. That is the first way, and this is the first gist. How to convert from the base 2 to base 8? You just need to use multiplication. How to convert the biggest base to the smaller and small base? You're using division. Only that. You know this formula, you can answer any of a question of this. We look at to the one by one, okay? So, how are you going to calculate this numbering? If let's say we've been asked to convert, we've been given hexadecimal number, we want to convert to binary. How? If we be given number that what they call octal, convert to binary. How? If we be given number by binary to convert to hexadecimal, how? How to calculate? So I said to you, bigger to small base, we're going to use division. Divide with the particular unit of the bases. If we want to convert and calculate from the small base to the bigger, we're using multiplication. Okay? Next. I don't want to waste the time. Some of students still sleepy. Okay? Wake up, wake up, wake up, wake up. All right. The numbering, okay, in binary, one thing you need to know, we have a sign magnitudes. This is what I call sign magnitude. So we talk about the sign magnitude is to show either the number is a positive or negative. This is not important now for you, all right, but it's important when we go to the part 2 of numerical system. Part 2 involved with calculation. How we going to calculate binary number, okay, if it involved with the operation like multiplications, subtractions, and addition. Done. So now it's not important. You need to know we have a positive number and negative number. How? It has a sign magnitude. Where? Look at to this one. If you look at to this, okay, we see here. Okay, the first digit here. The first digit at the front of a number is positive, 0, okay, and 1 here. So if you look at this one, this numbering basically is representing 18 in decimal, or our language is 18. But when they convert it to the binary, you need to understand computer instruction only accept 8 bits of words, or 8 bits of digit, or 8 bits of character, okay, to that particular instructions. So binary taking 8 bits. You just calculate the location here. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? But we start to calculate the positioning, also important, which is we're going to start the most right side here, from behind. Okay? Then if you look at the binary number here, the most frontal here, most left here, significantly 0. 0 in numerical system representing positive, and 1 representing negative. You know, the challenging part in this, you know, basically when we want to do calculation, when it has the flow. Okay? For example, if you look at two complement later, you see the overflow. Imagine that you want to have 1 plus 1. 1 plus 1 in binary. They're going to have overflow. on your leftmost. So just remember one thing in this slide. Positive number represent with a 0 and negative number represent with 1, and we call it as a sign magnitude. Let's we go to the 2 complement. 2 complement also we call as a, what we call it, binary or 2 base. All right, and then just take a look later, okay, for your own independent study. Look at to the range, number representation, and so on. Okay, I'll skip this part. And then if you look at to the 2 complement in here, in my tutorial, I teach my students how to calculate the increasing number of the bits for 2 complement. So I skip now. Next, range extension. So we talk about range extension. 2 complement, it means 2 power by 2. Sorry, we're using a 2 complement, we're using a number 2 for the calculations, range extension. Okay, so it will be increased 1, 2, 4, 8, 16, 32, 64, 1 to 8. So increase because it's using power 2. And then see the numbering. The name also binary is only 11000001. You're going to see the numbering like this. Okay, the first one in here. Okay, the first one in here. My pen problem again connecting to this. Let's switch it. Yeah, my pen problem. Look at the 1100, 1100, and then complement 2. Superside, you see 2. So first of all, what you need to know is the positioning. How many of digits in here? 4. So the first positioning in most right, the most right positioning is 0, right? From behind, 0. Next, after that, 0. I talk about this one. Okay? And then after that, we have 1. And the front is a 1. So you're going to take a look on the positioning, the last positioning, on your left and your right side. So on the most right side, we have a 0 here. So you need to see, is this a complement 2? We're using 2 bases. So look at to the last one in the parenthesis, 0 times by 2, multiplication. 2 power by 0, because positioning first, the most on the right is 0. Okay, and then we're going to see the second positioning, 0, 0. So we look at to this one positioning, the most is a 0. So 0 times by 2 power by 1, because positioning here is 1. If I want to change that, is this numbering is a 12, is negative, so I'm going to have a 1, 0, 0, 0, 0, and then I continue another 4 bit 1, 1, 0, 0. So that's not important. I don't want you to think about that. Now we go to decimal. Look at to the decimal. Decimal is a power by 10. Sorry, base 10, not power by 10. If you look at to that numbering, okay, so we have a 12. That numbering is actually, okay, 12 is decimal. Our number, we understand there's a 12. And 120, what's the difference between these two numbers? 12 is an integer, okay? And 12, behind, at the bottom, below that, 120, dot 1 is a fraction number, is a real number, decimal point. So what we're going to do, same, we do a multiplication. For this decimal number is power by, base of a 10, if you look at that 10. Taking the positioning, we have a 2, the most of the right digits, 2. So what's positioning of a 2 in here? What's positioning of a 2 in here? 0. So we're going to take 2 times by 10, power by 0. And then look at to the next number is a 1 in the front. So 1 multiply or times by 10, power by 1, because positioning is 1. But if we talk about fraction number or real number has decimal, look at to the decimal. I coloring with the red color in there. Okay, before the dot, before the point. Okay, placing will start before that. So we have 1, 2, 0 here. Yeah, we have a 1, 2, 0 here, right? So that 0, we're taking the place as the first counting positioning. So we're taking 0 there. Look at that. We're taking 0 there. So we have a 0 times by 10 power by 0. 2 times by 10 power by 1. Okay, and the last 1 times by 10 power by 2. So what happened to the decimal point? Number 1, the last, on the most right hand side. Number 1. Because of it's after decimal, it's going to be -1. Okay? And then if let's say we have the numbering 120.13. So the 3 we need to times by 10 power by -2, -3, -4, and so on. That's the way. Yeah. Octal base 8. When we talk about octal base 8, same thing. We look at to the positioning again. 14 base 8. So 14 base 8, 4 is a positioning 0, 1 positioning 1. So we're going to talk about this one. 4 times by 8 octal 8. Okay, power by 0. And then 1 will be times by 8, and then positioning is 1. That's why that is the reason that is the result. Okay, same goes to the 170 without further delay. Next is a decimal 16. Just 16, change it. But it's very wonderful about the 16. And we have a clashing conflict of information about hexadecimal and decimal conversion. Later, I will let you know. Okay, we talk about the hexadecimal. As your friends answered just now, hexadecimal or base 16 is actually calculate the bit for the base 16 and then the numbering until 9. Why is not until 10? Because if until 10 is a base 10. Okay, so the numbering for base 10 is actually completely perfect. It's completely perfect, like our hands. You know, one thing that I want to share, previous of researcher when they are come with this ASCII, you know, ASCII format, they're calculating how we're going to use the numbering representing the number to any certain of object in the world, and you want to count. So that's what the question they ask. We're using our finger, 10. That's why we have a decimal base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's easy. So they said, oh, if we have like an alphabet and so on, how are we going to representing that? It's too much, too many. So they said, we use hexadecimal. By the end, that each of a number has a basis. But that's not the important. The most important is we go back to this slide. All right, hexadecimal only until 9. Why is not 10? Because of we have a decimal. Until 9. Start to the 10 is going to replacing to the A. B, C, D, E, F. A represent number 10. B represent 11. C represent 12, and so on. So that is hexadecimal. Okay, but why is until 15? You will ask me. Because if hexadecimal, we are having 16th base. So until 15, that is the truth. All right. So same thing also. We take on the allocation, the positioning, numbering, and we convert. The process conversion. Okay. Only 2 steps. If the small base to the biggest base, you're using multiplication operation. But if a bigger base and you want to convert to the small base, you're using division. Let me see first of all. Together. Okay, binary to hexadecimal. Wow, binary is a small, hexadecimal is the biggest. How are we going to make it that? So this is numbering. What? 11110. And then 1100, 11010. Wow, that's a lot, you know. And that numbering you see in the binary representing ECD6. Is it? Yeah, 6. All right. So how we going to convert it? Dr. Sari said you need to multiply. Yes. But we also have a shortcut to do that. If you're able to calculate the binary number increments, okay, as I shown to you in the tutorial, so you can make it like this. So when we split to the 4 digits from the most right side, okay, we need to convert the most right side, which is if I'm taking that, I'm going to take 0, 1, 1, 0. You separate that 4 digit, another separately 4 digit, then another next 4 digits. So this is one way. Okay, when you separate that, you can know, oh, this is basically the first step for you to convert to hexadecimal. But as I mentioned to you, be small to the bigger, better use multiplication. Back to the same concept as I showed to you just now. All right. Look at to the positioning of the numbering, that binary number. And we look at to the positioning of the numbering number. Okay, this is positioning, the first positioning 0. So 0 was 0 here. And then I'm going to take positioning 0 here. So I take in 0 here, 0 times by 2. And then I have positioning here 1. Okay, so I taking 1 here, 2 power by 1. Taking positioning, this is 2. So 0 here, 0 times by 2 power by 2. And so on. When you multiply all this total, okay, you need to have a addition operation here. Okay, total up, you get that number. But when you total up, get the number 106 or 106 is actually decimal. Our objective is to convert binary to hexadecimal. So not finishing yet. So when we talk about, in this case, we got the decimal here. So decimal to hexadecimal. Decimal to hexadecimal. So we get to use multiplication also. So this one need to convert again, second time, because we convert to the decimal. So we learn something in here. Binary to hexadecimal, whatever number you want to convert, binary to other bases, okay, actually it's better to convert to decimal system or decimal numbering system base, because of it's easy for you to convert to the others. Like this example, I straightforward to give you an example for binary to decimal, and then decimal to go to the hexadecimal. Okay, so okay, anything you want to do you have a question? Anything clear? Right. So let's we go to the next. Easier. Binary to decimal, same thing. Binary to decimal, we're taking the positioning, and then because it's decimal, our number, we understand that, times by 10, right? So if a binary taking the place, you see a same thing also the solution. Giving the example in here, we have here 1101. I want to convert to decimal. So I said using multiplication, taking the first most of a right side digit 1. So taking positioning, 1 is a 0. And 0 here will be taking here 0 and the positioning 1. 1, 2, and 3. How many positioning? 0, 1, 2, 3. 3 positioning. So multiply that. 2 power by 0 actually is a 1. And then 2 power by 1 is actually 1. But the thing is here 0. So anything multiplied by 0 becomes 0. So you total up with 13. So we got that the answer. Easy? Any question from behind? Okay. Binary to octal also is the same, but the thing is octal. All right, binary to octal. So if you look at to this one, we have a 2 operation. In the first place, I'm going to change binary to decimal. Same goes to the previous example, binary to decimal. And then decimal to hexadecimal. Same goes like here. Binary to octal, what we're going to do, we change to the decimal. Taking the place positioning, multiply by the positioning, total up the number, and then you get decimal. Same thing, yeah? So for example, in this case, if you look at the numbering in the binary, I give it to you. All right, we have here 1010101. So this is binary. I need to change to the octal. So to the octal actually is a 8, right? To the octal. Now, first step, we change to the decimal. Anything, any bases, okay, whatever you are going to do convert, as long as you start with binary, change to the decimal, base 10. That's the most easiest. After you got that base 10, then easy for you to convert to the other number. Please don't confuse yourself. Very simple things. Take the positioning. So the first positioning from the most right is 1. Yeah? So what is the positioning for 1? Digit 1 is actually 0. So taking 0 here. 1 multiplied by 0. 2 power by 0. The second is 0, 0. And don't waste your time. Any of a numbering you see 0 here, for example here, 1, 0, 0, 1, 0, 0, right? There's no value. Because 0 times by any number, it becomes 0. Don't waste the time for you to calculate that. All right, so 64 plus 0 plus 16 plus 0 plus 4 plus 0 plus 1. So this is the value you got. Actually is 85. So if you look at the 85, this number is a decimal number, base, right? Our number. So, but our objective is to convert to the octal base. So if I want to convert to octal base, remember my concept. I said to you the gist of this topic. The bigger base, to change to the smaller base, you need to use division. That's why, you see, now we will convert this decimal to octal. We're using division. Why? Decimal is bigger, ma. Okay, Liao? Chinese. Okay. Bigger. So now, we got decimal. 85 is decimal number. I want to change to octal. Octal small, right? So when we start from the big number to the small number, we're using division. That is the thing. And when you divide, okay, because when you divide, you need to see first actually what the base you want to change. If octal, you divide by 8. If the change to hexadecimal, so divide by 16. Okay? So if you divide and look at to the calculations of division, I already put an example there. Okay, you're going to take the remainder of that means the balance. So when you're going to take, as long until that you get the numbering is a 0. You divide until the smallest you get 0 at the end. Take it the 0, stop. Do division, okay, and then calculate from the bottom to the top. So this result will be 0, 1, 2, 5. If you're not confident in your midterm test later, is it I need to write down 1, 2, 5? Or I taking the 0, just write that number, 0. Put, all right? As long it has a number there, I accept and it's going to have a marks. Okay, any question? We have a time with a tutorial, we go in detail. Another example, decimal to binary. Decimal is a bigger base, so we convert to binary. So, divide. See how we calculate it. Okay, back home, next week we have tutorial, you do exercise on doing this. Okay? Just take a look a few moments. But the difference in this example, if you look at to this example, okay, on the right side, okay, I'm using fraction number 10.625. So how are we going to calculate if we deal with the fraction number or real number? How are we going to deal with this? There, I'm giving you the answer already. How we deal with that? We're taking the most of the right side and the most left side. Okay, the most right side actually is the after the decimal point, which is the digit is a 625. Okay, and then the most left is a 10. So you need to divide the 10 that digits. Divide first, okay, and you got the remainder. Taking that 0, 1, 0, 1, 1 from the bottom to the top. So what happened to the fraction number? I say it's negative, right? When the negative, we're taking a look on that, which is if you change that 0, 6, 2, 5, it's become that number. All right. So when you multiply this operation, it will revert to have a 1 in the front. You're taking the value, the first decimal point. It means in the front, 1, 0, 1. The arrangement will be from the top to the bottom. But I don't like fraction number. Don't worry, I'm not giving you fraction number. Ah, lucky. I'm not going to give you fraction number in your midterm test. This one will be in your midterm test. This question in MCQ. All right. Decimal to hexadecimal, quite a little bit, we look at to this one. This is the thing, little bit complex, because you see decimal is a small base, right? I told you small base, to go to the bigger base, you need to using multiply, right? But what is using division? In here, only this case, only this, the last gist for today's class, only this. Why decimal to hexadecimal, we are not using multiplication? As well, we understood decimal is a small number. Hexadecimal is a bigger number. Am I right? We should to use multiply, but here why we using division? Anybody can answer me? Only this, okay? Only this. Only this. Decimal to hexadecimal is a little bit different. Okay. Okay, my friends here. What's your name? Khalid. Yes. Khalid, where you come from? Yemen. Okay. Khalid said, why? I asking that question just now, right? Why decimal to hexadecimal we're using division, not multiplication? Khalid said, decimal and hexadecimal is a same level. It's a huge number. Both is a huge number. Anybody agree about this one? It's a huge number. Decimal is a 10. Hexadecimal got 9 A, B, C until 15th. 2 is biggest number, but hexadecimal seem like biggest, right? I want to tell you. If we go back to the first slide just now I shared with you, did you see the numbering? Let me see. Who is the biggest? Khalid said both is the biggest numbers. I agreed. Absolutely, I agreed, Khalid. But look at to the slide. Back to the slide. That's why I really like this table. Compare decimal and hexadecimal. Both is a big numbers. But which one is the biggest? Which one is the beast? Decimal. Why? Decimal. Decimal uncountless. Okay? It's countless. Until thousand, billion, trillion. Hexadecimal until 9 only, ma. So we understand, before you step up my lecture today, actually hexadecimal is smaller than decimal. Okay? So when it's smaller, back to the concept, the first concept. We're using what? Smaller to the bigger. We're using multiplication. Bigger to the smaller. We're using division. So back to this question before I close today's lecture. Okay, let me back to the question. Decimal convert to hexadecimal. All right, look at to this one. We're using division. Why? Dr. Sari, why? Because hexadecimal is smaller than decimal. Although decimal is same as well as the hexadecimal is representing bigger number. But when we see the representative of the numbering base in the 2 complement, decimal is a bigger. All right? So that is the reasons. So we're using division. And the last, okay, same thing, octal to binary, which is octal, big number, to the small. So the big number to the small, what I said to you, using division. Hexadecimal to decimal, okay? Look at to that. This is the way how we are doing. We understand that whatever number after 9, 10, 11, and so on, we're going to change to the alphabet A, B, C, D, and so on. So only this for today's topic and the gist. Remember, we do exercise. So I don't want you to overthinking about this topic. Actually, numbering system is so fun, and then just need to know how to convert. Don't confuse yourself. So next week, we're going to talk about this in detail. All right? We do exercise together, then you know. Not only surface the skin. Any question? Really? Okay. Chop, chop. Dismiss this class. I will take attendance. So class are going to remind you, make sure that you key in the groups of your group members for your assignments, all right? Okay, try to find your group members. And yeah, again, I want to announce, before you go, relax. Hungry, want to have breakfast. Okay, before you go, please, I want to get only 1 minute from you. Listen. Listen, please listen. All right, so for the group, please key in your group members, okay? And then the new instructions, minimum 2 people in one group. Minimums, 2, not 3, minimum. Group members in one groups. And then maximum 6, okay? Thank you. Those who are taking the attendance, you may go. Thank you. I appreciate that you're coming today. All right. Bye-bye.